select the major product of the following reaction sequence. And so we are starting here with an unsubstituted benzene ring, and we are taking this through two separate transformations. So we want to recognize in this first step is that if we use a molecular halogen, like chlorine or bromine with this Lewis acid catalyst, that these are the conditions to do an electrophilic aromatic substitution reaction. And specifically what you're going to be substituting here is one of the hydrogens of the benzene ring with a chlorine. So this is an EAS, electrophilic aromatic substitution chlorination. So after this first step with our chlorine and the Lewis acid catalyst, we will have replaced one of the hydrogens on the benzene ring with a chlorine. And since this was initially unsubstituted, it doesn't matter where we put the chlorine, we can put it anywhere at all on the ring. And then we want to take a look at the second set of conditions. So we have fuming sulfuric acid. So this means sulfuric acid that has extra sulfur trioxide in there. And that's just to make this a more powerful electrophile. So this is again an electrophilic aromatic substitution. And in this case, this is a sulfonation. So adding a sulfonic acid group, SO3H. And so let's draw these conditions over the arrow. And this time we are not starting with an unsubstituted benzene. Our benzene ring has a substituent on there. So we need to know what sort of directing effect this chlorine is going to have. And so the halogens are ortho-para directors. So these are going to activate these ortho positions and the para position. And with the sulfonic acid group, so this is adding SO3H, that sulfonic acid group. This is a really large group. That sulfur that's going to be directly attached to the ring is going to have 3 bonds coming off of it. So being that large, it'll have trouble fitting in to these ortho positions because this ring is flat, which means that all the bonds are sitting in like the same plane. So this is going to add primarily to the para position. So that means that our overall product is we will have the chlorine and the sulfonic acid group para or 1,4 to each other on the ring. And we can take a look and see that this corresponds to option A.